We're going to continue with our examples on optimization. This problem is similar to number 1, but instead in this problem we're trying to find the least amount of fencing instead of the maximum area. Alright, it says that we are enclosing a pasture against a river, and we want it to contain 180,000 square meters. That tells me that's the area. And if I label this Y and X, we know that the area is going to be X and Y, which is 180,000. It wants me to figure out the least amount of fencing to go around the area needed. So that means that we're going to be dealing with a perimeter here. There's another Y here. So the perimeter, which is what we're trying to find the least of, is X plus 2Y. So we're going to solve for either X or Y in the area equation, and we're going to plug it into the perimeter equation. Because the perimeter equation has just an X right there, I'm going to solve for X in the area equation. You can solve for Y, it just makes it a little bit more difficult when you're multiplying and working out the derivative. So I'm going to divide by Y. I get 180,000 divided by Y equals X, and I'm going to plug that in for X. And then I'm going to find the derivative. Now when I do the derivative here, I am going to have to use the product or the quotient rule or the chain rule. So if I'm going to do that first part of it, I'm going to rewrite it as 180,000 y to the negative 1. So when I do the derivative, it would be negative 180,000 y to the negative 2. I'm going to go ahead and bring that down because it's going to be easier to solve in a minute. The derivative of 2y is 2. After you get your derivative, because we're trying to find a minimum or a maximum, we set that equal to 0, and we solve. So we're going to subtract 2 on both sides. And then when you get to something like this, I'm going to put it over 1, and then I'm going to cross multiply. So I get, I'll write it in a different color so it doesn't all go together. I'm going to bring it up here though. Negative 2y squared equals negative 180,000. Divide by negative 2. Get 90,000. Take the square root on both sides. And I get y is 300. Because the question says what are the dimensions, I would need to go back and find x. I would probably plug in y into this equation here to get x. So x would be 180,000 divided by y. And so you would end up with x equals 600. And these are in meters. So if I create this rectangular pasture, to minimize the fencing, I'm going to need 300 meters on the Y side and 600 meters on the X side. Alright, number 3. Alright, we are enclosing 3,000 square foot in a botanical garden. So the 3,000 is the area. And again, we can label this as X's and Y's. Shrubs are going to cost $25 per foot along 3 sides, and fencing is going to cost $10 per foot. It doesn't matter which one you put it at because it'll work out the same. Our X's and Y's may be switched or whatever, but I am going to make the shrubs go here on these 3 sides. And I know these are fabulous shrubs, but that'll help us get an idea of what's going on. And then fencing is going to go on this side. Okay, so the shrubs are $25 per foot. So there are shrubs on 2 of the Y sides and 1 of the X sides. So it's going to be 25 times Y plus 25 times Y plus 25 times X. That's how much the shrubs will cost. The fencing is $10 per foot, so it's going to be 10x. Alright, so that's going to be the cost. And then the problem tells me to find the minimum total cost. So cost is this equation. It's the equation we're trying to find the minimum of. So to go back up here, I know the area is x times y. For cost, I would probably simplify just a little bit, because you can combine those y's and x's and you get 50y plus 35x. Alright, so in this equation you can solve for either x or y, whichever one makes more sense to you. I think for both of them you're still going to have to multiply by a number, so let's just solve for y, I guess. And then I'm going to plug it in here. So cost is going to be 50 times 3,000 over x plus 35x. Multiply that out. We get 150,000 over x plus 35x. Alright, so I have time to get to the other problems and to make sure that we have a chance to go over every single one as far as how to set them up. I'm going to let you finish this problem. So what you would do is to find the derivative. Once you find the derivative, you set it equal to 0 and then solve for x. The problem said find the minimum total cost. So after you get the x value, you're going to plug it back into the cost equation right here, and that'll give you the minimum total cost. As you're working out the problem, you're hoping to get x is 0.465, and the cost should be $4,582.57 or 58 cents. So you can check and make sure you're getting that correct. Alright, number 4. A rectangular swimming pool is to be built with an area of 1,800 square feet. So here's our swimming pool. It's going to have 1,800 in the middle of there. The owner wants 5-foot wide decks along both sides and 10-foot wide decks at the two ends. Okay, so we're going to have decks on both sides. Let's say that this is the 10s and this is the 5s. And so that's sort of what it looks like. That outside square part is the deck. Alright, find the dimensions of the smallest property on which the pool can be built, satisfying these conditions. Okay, when they tell you to find the smallest property, what they're asking you to minimize is the area. Okay, so we need the area of the whole entire thing. But then we're also going to be interested in the area of the swimming pool, because what we know about the swimming pool is that the swimming pool is built with the 1,800-foot area. So first of all, I know for the swimming pool that the area is XY and it's 1,800 square feet. And then maybe here's Y and here's X. So the area of the entire property, so if I look at just where the X is, it would be X and then 5 and 5. That's how long the total thing is. So that's X plus 5, which is X plus 10. If I look at the Y, we have this Y, but then it goes, because that's this part, but then there's also this 10 and this 10. So that would be Y plus 20. And that's the area of the entire part, or the entire property that it's asking me about. So this one's kind of different, but what you're going to do is still solve up here for either X or Y. It doesn't really matter. We're in the habit of solving for Y, so we'll just continue to do that. Alright, we plug it into this equation. Now to solve this and find the derivative and everything, you're going to need to multiply it out, like using FOIL. So I'm going to start with x times 1800 over x. Well, that's 1800. X times 20 is 20x. 10 times 1800 over x. Well, that's going to be 18 with 3 zeros, 18,000 over x. And then 10 times 20 would be 200. The reason for multiplying it out is it just makes finding the derivative much easier, because now when I find the derivative, well, the derivative of 1800 is just 0. The derivative of 20x is 20. The derivative of 18,000 over x, if you think of that as bringing it up and then rewriting, so it'd be negative 18,000 over x squared. The derivative of 200 is 0, so the derivative becomes much easier after you've multiplied it out. Again, I'm going to let you finish that. You set that equal to 0, cross multiply and solve. You should get x is 30 feet and y is 60 feet. Now, that x and y is for the pool. So after you get the 30 and the 60, you will have to go back to get the area of the entire thing, or the dimensions of the entire thing, using your x plus 10 and your y plus 20. And I'll let you finish that one as well. Alright, number 5. So this one is where we want to make a box out of paper, cardboard, whatever the material is. And basically what's happening is I'm cutting squares off of the edges. So I'm cutting a square there, 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 and there. And the length of the square is the same all the way around. And then the sides come up and come up. Alright, so it says that we have 24 inches. The box is to be made from a square piece of material, 24 inches on a side. So what that right there is telling me is that each side is 24. Okay, so this whole entire side here is 24, and this whole entire side is 24 as well. So it must have been a square piece of paper or something that says square piece of material. Alright, so we're trying to find the volume, and this is the only kind of equation where you don't have to make two equations. You actually can just make one. Okay, the volume here is going to be length, width, and height. And remember how I told you how when you cut those squares off, the sides come up. So the height of this volume, or of this thing, once you cut those squares off and cut it up, the height is x. Okay, and then your length and your width is going to be like this part here and this part here, because when you fold it up, those squares are folded in. Okay, well, if 24 is the whole entire thing and you're cutting off these two little squares, then the actual length that I'm looking for right in here is 24 minus 2 of the x's. In a similar fashion, if I try to find this side right here, it's the whole side, which is 24, and then you subtract off the 2 x's, so both of them are the same. And if you'll notice, we now have an equation of volume and of x, and I don't have to rewrite some other equation because I have two variables here. Now, again, for the sake of time, so that I can show you this last problem and get it set up for you, I'm going to let you finish this. What I would suggest that you do first is multiply. I would multiply using FOIL. I would multiply these two pieces together, multiply it out completely, and then go back and multiply what you get by x. After you get your equation, you'll find the derivative. You'll set it equal to 0. This one can be factored, or you may use the calculator if you need to help you find those zeros. The final answer, what you should get, is that the x should be 4 inches that you're going to cut off of the sides. And it doesn't ask you the volume, so the x value is enough. Alright, let's get to this last one. It's asking me to find the volume of a rectangular solid with a square base and surface area of 150 square inches, and we want to maximize volume. Again, I want to help you get this one set up. Let's think about what it's asking me about, and this will be the best picture I can come up with for now. But we have this square base. It kind of looks like this. And I know it looks like it's kind of sideways, but we'll just, this part right here is like the base, and then this part here is the height. Okay? So, as far as the volume goes, I know that the volume of this thing is length, width, and height. So the volume is x squared y. Alright, the surface area is where you have to consider each of the faces. Okay? If I look at the front, or really that's the bottom, and the top, the area of those two are x squared, and there's two of them, so it would be 2x squared. If I look at the sides, there's two of those. The area there will be xy. And then if I look at the top and the bottom, or the other two sides, again, those are both x's and y's. So really we have another 2xy, or just a total of 4xy. And that's what surface area is. I would set that equal to 150. Again, I'm going to let you try to finish this one. You're going to solve this equation for either x or y. I would probably pick y because there's x in both of those pieces. And because when you plug it into volume, it'll be easier. Once you find y, you're going to plug it in to there for the y. You are going to have to multiply that out a little bit. It will make the derivative much easier. Hopefully in the end, once you set it equal to 0, you'll get x equals 5. And because the question says determine the volume, you'll go back in to find the volume, and you should get 125 and it's inches cubed. So try to finish the rest of those.